All right, so today we're starting chapter 7, which is the first chapter of our trigonometry units. And if you've ever wondered on the mode menu, if you ever see radians and degrees, like what exactly is a radian, then today you're going to find out. So often in geometry, you're going to measure in degrees, like an angle is 30 degrees or 47 degrees or 310 degrees. But now we're going to be converting items to radians. And so the first order of business is figuring out what is a radian. 1 radian is the measure of the central angle whose arc length is the same as the radius of the circle. If there's an angle that's created with a vertex at the center, that's called a central angle. And you can tell that R is labeled as the radius, but then the arc length, which if you think about like a pizza, the pizza crust, that's this outside part, that measurement is the same as this measurement. So the arc length is the same length as the radius of the circle. 1 radian is equivalent to 180 degrees divided by pi, which we're going to show you different ways to convert to and from radians. I think this diagram is a good example of how big 1 radian is. So you have 1 radian, 2 radians, 3 radians in these angle measures, plus a little bit more, and that little bit more is to get you up to pi radians, which is equivalent to going 180 degrees if you were to measure in degrees. When you convert from radians to degrees or vice versa, you're always going to multiply, and you're either going to multiply by pi over 180 degrees or 180 degrees over pi. So the best way to think about it is the way that you do it in science class, which is dimensional analysis. So let's take a look at example A. So 30 degrees, if I were to make that into a fraction, that's in the numerator. I'm just putting a 1 on the bottom, so I know that the 30 is on top. And I'm either multiplying by pi over 180 degrees or 180 degrees over pi. But I need to make sure that the degrees would cancel out. So I need to make sure that the degrees are on the bottom. So I'm going to put 180 degrees on the bottom and pi radians in the numerator. And then you're just multiplying across and canceling out whenever possible. So the degree symbols would cancel out. 30 over 180, that's 1/6. And then I have pi over 6, or you can call it pi radians over 6, or pi over 6 radians. But technically, when you provide your answer, you just say pi over 6. You can leave off the radians word. So that's not a unit. Radians are technically unitless. All right, if you look at part B, it says convert 150 degrees. So we start with degrees, so that means I want degrees to be in the denominator. So I'm going to put 180 degrees and pi on the top. And I'm going to leave off the word radians here because we know that it's measured in radians. And so all I need to do is reduce as much as possible. This would give me 5 over 6. So this gives me 5 pi over 6. All right, and then the last one in this section, if you want to try it on your own, go ahead. But it's 300 degrees over 1. So I'm going to cancel out any common parts. So the degrees cancel. I could divide them both by 10. And I have 30 over 18, which I can divide both of those by 6. So that would give me 5 over 3. So that would be 5 pi over 3. All right, so now we're given angle measures that are in radians, and we need to convert to degrees. How do we even know that these are radians? There's no symbol here. All right, so if there's no units, then I know that this is in radians. And now I'm going to convert it into degrees. So I'm going to start with pi over 12. And I, again, need to either multiply by pi over 180 or 180 over pi. But I want the pi to cancel out. So that's a good hint that you want it to be as 180 degrees over pi. All right, also we want our degree symbol to be in our solution and in our numerator. All right, we also need to reduce a little bit. So 180 over 12 gives you 15. So your final answer is 15 degrees. All right, so pi over 6, well, that's twice as big as pi over 12 if you're good with fractions. So we should get twice as big of an answer. But let's do it with the conversion factor. So 180 degrees over pi. I'm going to cancel out my pi's. And then I know that 6 goes into 180 30 times, so that is 30 degrees. And then our last one here, we have pi over 4, so I'm going to multiply that by 180 degrees over pi. And then in my numerator and denominator, you see that you have pi's, so that will cancel out. And then 4 goes into 180 45 times, so the answer is 45 degrees. One thing to think about when you check your answers is to look at a pi radian is a semicircle. So half of a semicircle would be pi over 2. So any angle measured between 0 and pi over 2 should be between 0 and 90 degrees. So it'd be an acute angle. So if you're looking at pi over 12, pi over 6, pi over 4, those are all less than pi over 2. And so those should be less than 90 degrees. So the arc length is, again, like the pizza crust. If you think of this as a pizza, we have the outer edge, that's your arc length, and the entire slice, that's your area, and that is called a sector. All right, so how do we get these formulas? So S represents the arc length, R is your radius, and this symbol is theta. That's your Greek letter to represent your angle measure. All right, so I think that formula is pretty straightforward. This area formula is based off of an angle measure that must be in radians. All right, so it's 1/2 r squared theta. And all right, so how do we get this area formula for a sector? So we're thinking of our angle that's measured in radians. But if you think back to geometry, we all know that pi r squared is the area of a circle. And if we were to figure out an angle, a central angle, out of 360 degrees, that would give us what portion or percentage of the circle that angle takes up. And so we would take that portion or percentage and multiply it by the whole area of the circle, which is pi r squared. So we're going to do the same thing, except instead of thinking about it in degrees, we're going to think of this angle being in radians. And so an entire circle is 2 pi radians. All right, so let's just simplify this formula a little bit. You can see that there's a pi in the numerator and denominator, so that cancels. And so you're left with a 2 in the denominator, which is also known as a 1/2 as a coefficient. So it's 1/2 r squared theta. All right, so the first example says find the arc length in terms of pi. And so again, arc length is the pizza crust. So this 4/3 pi, that's more than 180 degrees. So in case you're confused as to which angle it's referring to the larger of the two angles. And we want to figure out what's the length of the edge of the circle. So we're going to do arc length equals radius times the angle. And the radius is labeled as 3 feet. The angle is 4 pi over 3. And then you just have to simplify. So we know the 3's cancel out, and we're left with 4 pi feet. If your radius is measured in feet, then your circumference would need to be measured in feet, and therefore your arc length, which is a portion of the circumference, that also needs to be measured in feet. All right, so again, we're going to do one more arc length example. So we're going to do arc length equals radius times theta. So this time the radius is 2 centimeters. And we can't use the angle as 45 degrees. We need to first convert that into radian measure. So we know that every 1 pi in radian is equal to 180 degrees. And so we're going to do pi over 180 degrees. And we know our degree symbol will cancel out. And 45 over 180 is 1/4. So you're left with 1/4 pi, or pi over 4. So going back to our formula, it's S equals radius times the angle measured in radians, which is pi over 4. So now we have 2/4 or 1/2 pi centimeters. And notice it's not centimeters squared or feet squared. These are linear measurements. All right, moving on to the next problem where it asks you to find the area. That's where we want to use this formula, area equals 1/2 r squared theta. So hopefully they give you all of the information that you need. And in this case, they give us our radius, which is 6 centimeters. And they give us our angle measure in radians. Notice that there's no degree symbol, so this is in radians. And so 2 pi over 3 gets substituted there. All right, make sure that you square first. So we have 1/2 times 36 centimeters squared times 2 pi over 3. And then try to simplify as much as possible. So the 2's cancel out, and 36 over 3, that's 12. So we're left with 12 pi centimeters squared. And be really careful with your units. It is an area, so you should have centimeters squared. All right, and in part B, notice that they give us an angle measured in degrees, so we're going to have to convert 80 degrees into radians. So we're going to multiply by pi over 180 degrees. And so we're going to simplify that. And we know the degrees cancel out. We could divide by 10. And we could also divide by 2. So that would give me 4 over 9. So my angle measure in radians is 4 pi over 9. So once we convert the angle into radians, we can just use our formula, which is area equals 1/2 r squared theta. So our radius is 5 centimeters, which we're going to square first, and we're going to multiply that by 4 pi over 9. So 5 squared is 25, and now my units are centimeters squared. And then we need to reduce. So the 4 and the 2 will cancel out into a 2. And so 25 times 2 is 50 pi over 9, and my units are centimeters squared. All right, so for this last section, we're going to complete the circle and convert all of the angle measures that are currently in degrees into radian measures. So my suggestion is to label everything starting with pi over 6, and we're just going to count up by pi over 6. So pi over 6 is pi over 6 times 180 degrees over pi, and that becomes 30 degrees. So I'm going to label every angle measure that's 30 degrees or a multiple of 30 degrees as 1 pi over 6, 2 pi over 6, 3 pi over 6, and so on. All right, so now that I have everything labeled counting by pi over 6s, we can reduce many of these fractions. This becomes pi over 3, this is pi over 2, and so on. All right, so as you notice, the only thing that's left are the 45-degree multiples. So 45 degrees, if I were to convert that into radians, that is pi over 4. So now to complete our circle, we're going to label every pi over 4 or 45 degrees. So 45 degrees is pi over 4. 90 degrees is 2 pi over 4, which reduces to 1/2 pi. Then 135 is 3 pi over 4. 180 is 4 pi over 4, which reduces to pi. 225 is 5 pi over 4. 270 is 6 pi over 4, which reduces to 3 pi over 2. Then we have 7 pi over 4 for 315, and 8 pi over 4 for 360, or 0 degrees, which reduces to 2 pi. So the biggest takeaway for today is to make sure that you know that 180 degrees is equal to pi radians, and you'll be using that conversion factor to change from degrees to radians or radians to degrees throughout the whole chapter, as well as the remaining trigonometry chapters.